Hi guys, I've never did a YouTube video. This is my first attempt at doing one, and this video is going to be on how to install a PlasmaAir, PlasmaPure Model 603 air purifier. I guess the first question that one might ask is, why am I installing an air purifier? About a year ago, I had a new heat pump installed, and it was working great, but as it got to be the fall winter time of the year when the actual heat started coming on, I started smelling an odor, which any one of y'all may have, if you've experienced it, you know what I'm talking about, and it's called the dirty sock syndrome, which I think all the HVAC manufacturers have this issue. I personally think that they'll tell you that it's not their issue. I personally think that it is, and that they should be held accountable for that, but I won't go on a rant as part of this video. As part of me having that issue, I reached out to the folks that installed my unit, and they actually, through Train, got a replacement evaporator coil for my air handler and installed it. The replacement coil was actually coated, and I actually printed out a picture of that I will show you guys. So basically the original one was all just shiny aluminum. The one that they replaced it with is coated, but as you notice, and this is a Train model, that Train, their factory replacements, they're not coating the whole coil. The theory behind dirty sock, as I've been able to understand it, is that the micro indentions in the aluminum allow bacteria to kind of form because of the moisture that accumulates on the evaporator, and given that the actual temperature that the coils reach actually is almost like an incubator for that bacteria, and in some houses that will actually cause that bacteria to grow, which will then lead to that smell whenever the unit comes on. Whenever you have that issue, like I said, when I had it, I reached out to my HVAC guys, and through Train got this evaporator coil replacement. Train used to have the installers take the evaporator out, they would send it off, it would be completely coated, and come back and the installer would install it, and that should take care of it, because that coating actually is almost like, it's like a epoxy type of coating that basically coats the aluminum such that the bacteria can't form. My particular problem that I have with Train is that, as you can literally see, they don't cover the entire evaporator, and so since they didn't, every once in a while I would smell a remnant of that dirty sock. That did help the problem significantly, and I truly believe if Train coated their coils, their newer factory coated coils, I don't think there would be a problem. But nonetheless, that's as far as Train will take it. So then I started looking at a way to purify the air and make sure that I had no remnants of the dirty sock bacteria. In looking at that, there are basically, from what I could tell, three main solutions for the problem. You either actually install a UV light that shines on the evaporator, or you look at one of a couple other types of purifiers. The UV light does two things. It'll shine on the coil, but also as air flows through the ductwork, the UV light will kill any bacteria that's in the air, so it's also purifying it. The other solution that some installers use are ones that actually produce a hydrogen peroxide. There's one called the Scubber by Aerus. There's the Reme Halo. Those also also use a UV light, but the UV light is encased in a metal, and the composition of that metal, when heated by the UV light, actually gives off hydrogen peroxide, which indeed any bacteria or virus type of stuff that comes in contact with that is purified out of the air. The third alternative, and this is the alternative that I decided to go with, is an air ionizer. There are different manufacturers that make them. There's Nu-Calgon, there's Bipolar, and there's PlasmaAir. I decided to go with the PlasmaAir, PlasmaPure model. They make it in 3 different submodels. There's a 601, 602, 603, and 604. They look all the same. The only difference is the power that's required to operate them. I'm choosing to go with the 603, which runs off of 120 volts AC. That unit itself, and this box here, my first one came in a retail looking box like this, and it actually came in a little packet. The second one that I'm going to be installing today came in a much more generic looking box. The unit looks the same. It has 2 little brushes on it that gives off the positive and negative ions. It has a green LED light on it, and it has a very strong magnet on it. From what I've been able to see, all of the manufacturers that make ionizer type air purifiers have a magnet mounting option. I am not particularly a fan of that, and I'll detail that a little bit further, but I will be using the screw options. And this unit is very small. It's 3 1/8 inch wide, 1 1/4 inch high, and 1 inch deep. When you go to, and I'm starting out this video, as you can see, my attic door is open, but I'm starting out this video downstairs because it's hot in the attic at the moment. So I just wanted to be able to talk through some of this before I go up in the attic and show a little bit more and actually do the installation. Whenever you're installing one of these units, you can either install it in the ductwork itself, and you can install it on the return side, which is where the air comes into the air handler. You can actually install it in the air handler, or you can install it on the supply side, whichever one you want. I think with the UV lights, you can do either one, but if you're trying to get rid of dirty sock, they specifically normally say do it where it shines on the evaporator. Well, in my case, that would be a very bad option, and I'll go back to the picture that I had of my evaporator. Now that I have a coated coil evaporator, Train, my HVAC installer reached out to Train, and indeed the coating that they put on their evaporators, whether it's the older way they used to do it where they would send it off or their new one, neither one is UV rated. Also, you may or may not be able to tell from this picture, the input coming in at the bottom and the top of the evaporator coil, that's plastic. And also, if any of the UV light actually makes it through the coil, the drain pan is plastic. None of their plastic pieces are UV rated. So I would be very careful if I was going to consider using a UV solution. The hydrogen peroxide solutions, normally they recommend putting them on the supply side, meaning the exit out of the air handler. Those particular solutions, my understanding is they work well. Actually, a couple local installers actually use the air scrubber model. The problem with those is, though they work, they're on the supply side, so they don't address any of the bacteria on the evaporator itself. It's just purifying it before it comes into the house. I didn't particularly like that, nor do I like the aspect of the actual hydrogen peroxide being in the air. But the biggest, number one thing was that both of those units still use a UV light that's encased in this it's a mixture of alloy, that the heat from the UV light is what generates the hydrogen peroxide. Those replacement units, since it is a UV light, regular UV lights have a life expectancy of a couple years. They might actually not burn out within the 2 years, but my understanding is their effectiveness is basically depleted after a couple years. So the UV lights you have to replace every couple years. They're anywhere from $50 to $100 depending on the model. And if you got one that had 2 bulbs, of course you double that price. The ones that use the hydrogen peroxide solution, those replacement, they call them sales. Those sales are upwards of $200. So every 2 years, you're forking out, even though they work, you're forking out $200 to keep the air purification working as it should. With the ionizers, there is no replacement parts. The only thing that, there are some actually air purifiers, some of the manufacturers make some that have a little wigwag on top that rubs across the brushes that wipes them off, because they will attract dust. And so they say that periodically you need to clean them off, and how often is a function of how dirty your environment is. It could be 6 months. In talking a lot with the PlasmaAir folks, they were very nice. As a matter of fact, I talked to multiple ionizer manufacturers, and if you use a good filter, you know, like a MERV 11, you can probably get by with wiping them off once a year. And if they get dirty, that doesn't break them, it just reduces their effectiveness. So you do actually have to clean these little brushes off unless you get a model that doesn't require it or that automatically cleans it. And on that note, I'll show you a brochure that came with the first one. PlasmaAir actually does have some other models. They have one model that you can actually, that actually does have a little cleaner that rubs over the ionizers, and then they also have a 7200 series, which is quite nice, but it's also quite expensive. And they use what they call needle ionizers that don't collect the dirt. And they're actually recessed, so you never really have to worry ever about cleaning them. But they're about 3 times as expensive, 2 to 3 times as expensive as the 600 series. So I just opted to go with the 600 series. The other thing is that the second one came with these instructions, and I wanted to point this out because what a lot of the ionizer manufacturers will recommend if you want a simple installation is just stick the ionizer on the blower so that the air comes across the ionizer and then gets sent out into the room, and then you just can actually screw your 2 wires down to the board in your HVAC unit. And you'll notice one of them actually is fused. The black wire is the fused, the hot one, and then the other wire, the white wire, is the neutral or return. I personally don't trust the magnets. One, you know, all HVAC blowers have some amount of vibration, so if you've mounted this thing vertically, not only do you probably have some little bit of tension on the wire that's going to want to pull down, but also, since the magnet it's not rubberized on the back to provide any extra grip, though it is exceptionally strong, I can see where that might work its way down over time. And I do know that one of the other manufacturers specifically say don't get anything within 2 inches of, no metal objects within 2 inches of the brushes, that can cause the unit, you can hear a little bit of a hiss, and that it can cause the unit to prematurely fail. So I don't particularly like that. Also, on my first unit, as I was, and I'll show you this too, as I was making a mounting bracket and I had to pull it off the mounting bracket 2 or 3 times, and like I say, that magnet is exceptionally strong, the actual adhesive off the back of it came loose. So I think PlasmaAir should probably work on that a little bit. I think some of the other manufacturers recess the magnet so it's flush, and maybe they are actually able to get more adhesive, or maybe use a different type of adhesive, or I don't even know if they're even any better at that. But I don't think I would trust just using a magnet mount. Now, also, the other important thing is, how do you want to mount it? Do you want to mount it on your air handler in the return duct? Do you want to mount it right in the air handler on the blower? Or do you want to mount it on the supply side where the air exits? No matter which way you do it, and this is true of any of the air ionizer manufacturers, is notice the way I'm holding it, where the brushes are making like a field goal. You want the air to flow across the ionizers this way, so that air blows across it, the positive and negative ions get pushed on through the system. You do not want your airflow to flow this way or this way, either way, where the ions from one brush go straight across the other. My understanding is that will cancel out the ionization effect and you won't get the desired purification. So you want to make sure that your air flows across these like the football going through the field goals. So in my case, since what I'm trying to address and what I want to make sure I address is I want to purify the whole air handler and get the ions out into my house, I want to install it on the return side, meaning the air where it gets pulled in from the house and goes into the air handler. So to do that, there's not really a good place to mount it that would allow me to mount it like this or this, where the air could go across it without using some type of bracket. So what I did was I actually made my own bracket. In doing this, I used very simple parts that I got all these from Home Depot. There was comparable pieces from Lowe's. I'm sure you can get them from different hardware places. What I started out with is basically a 2-gang electrical cover. This is actually, my first prototype used a metal cover. That turned out not to be so good because the screw holes to mount it were like here and here. So then after I got it all ready to mount, I realized that once I cut my hole in the ductwork, well, there was no metal for my screws to mount into because I had to cut it away to insert this into the hole. So alternately, I found this one here, which is actually made of plastic, which is actually, though, a much better cover because one, it's very rigid, it's not flimsy plastic, and the screw holes are much more at the corner. Not only that, the actual gasket for the cover is actually glued in place when you buy it, and so you don't have to worry about it flopping around as you try to get it in place. And dealing with the plastic is much easier to drill. Now what I did was in the construction area, I found some brackets that are used for binding like 2x4s together, one being a right angle bracket and the other one being just a flat tie piece that you'd use to tie two pieces together, because I wanted it to extend into the ductwork approximately 3 inches, because inside my ductwork there is insulation. So you want it to stick, you want your ionizer to stick inside the ductwork far enough to where indeed the air flows across it well. You will see there are some different holes here, so if you, for your installation, if you wanted it not as deep or a little bit deeper, you have some flexibility there. So, and these are galvanized, so I don't have to really worry about you know, rust or anything like that. The screws that I used are number 8. Most the ones right here that mounts the right angle bracket to the plate is 1/2 inch, as is the one that mounts the 2 metal pieces together, and then the 2 screws that I'm actually going to mount the ionizer to is 3/4 inches. And notice that when I bought the pack of screws, they came with nuts, and I put a nut. The nut is holding the screw in place, and what that really is doing for me is a spacer. That nut is basically the same thickness as the magnet. So whenever I slide the ionizer into place, not only will the magnet catch, but whenever I go to then screw it in place, I don't have to worry about tightening it down too far and hurting the ears, because this is providing a nice spacer for me. And for all of my connections that are rigid, I use nylon lock nuts. And so, and then what I also did before I mounted this and I marked the holes is that I used a regular electrical type of connector, or an interface that allows you to go through metal, so you don't have to worry about catching your wiring on any sharp object. I actually marked that. I drilled both the cover and then the bracket separately using a 3/4 inch bit, and then I took a round file and filed it out to get the right diameter to be able to mount that. So there's my bracket, and I'm going to mount the ionizer to it. And once I mount the ionizer to my bracket and run it through the hole and get all of that set up, on the end of the connections, I actually use a polarized 2-prong adapter, or not adapter, but receptacle, a male receptacle, because the expectation is that the black goes to hot and white is to return. So a year from now, if I want to unplug it and unscrew this and pull it out to check the brushes, and I go to plug it back up, I don't have to worry about getting the leads reversed. I can't get that wrong. These leads are about 50 inches if I recall, and I do have a receptacle. I actually had to add a receptacle in both locations to bring an AC receptacle closer to my air handler. And so I have one close, and so basically I was able to add just an AC receptacle right to the end of these leads once I got it mounted, and was just able to cut my hole in my ductwork. I pre-drilled the screw holes a little bit, just as like little pilot holes, and then I mounted it and plugged it in, and that's it. One thing I'll go ahead and mention while I'm down here, I'm trying to mention as much of this downstairs as I can, again because it's hot, is that when you do plug it in, you'll see this green LED will light up. My understanding is from the manufacturer is that you can assure that it's working. Somehow the LED is in the circuit such that if that LED isn't working, indeed the ionizer is not working. or if it's on, you can make sure it is working. The other thing you can do, and I got this from PlasmaAir, the PlasmaAir representative, because when you look at that LED lit, you don't see anything doing anything. So it's like, is this thing really working? What you can do, but you need to be careful doing this, is with it plugged in, you can take your finger and actually run it between the ionizers. You do not want to touch either of the brushes with your finger. My understanding is it can give you a mild shock. I don't know what the definition of mild is. You know, do that at your own risk. I did do that with my other one, and I will do that with this one before I insert it, even you know, though the light, you know, will be lit, is that when you put your finger in between it, it almost feels like a breeze on either side of your finger. But what it really is the current that is creating the ions. So that actually, to me, gives me a better feeling that indeed the item is working. The one last thing I'll say before we pause the video and I go upstairs is that as you can see, the ionizer brushes are at the very end of the little canister that they mount them in, and basically I think these little they're like little carbon fibers that come up on each side, and it looks like they got what looks like heat shrink tubing. It looks like they kind of crimp it together at the end and run heat shrink tubing down and heat shrink it before they put it in there and do that. The first one that they sent me, which is working just fine, but I'll show you this picture. In the first one that I mounted and installed, you'll notice that this one ionizer isn't quite in the corner. I did point that out to the Air Plasma rep, in that I feel that two things that Air Plasma should probably work on is they should actually, you know, one is the quality control. I think something like that, they should probably maybe not even allow something like that to go out, but it indeed seems to work just fine, so I didn't make too big of a deal out of it. The other thing is the adhesive that they use on the magnet. Since I actually did have the adhesive come loose with me, I do believe that they should work on that. Now, having said that, the reason that I went with Air Plasma versus either of the other two manufacturers that I'm aware of, being the Bipolar or the Nu-Calgon, who has a couple models, one that's very similar to this, and the Bipolar is very similar to this, and Nu-Calgon also has one with a wigwag on it. The reason I went with PlasmaAir is because, one, they're less expensive. I would say, depending on which model you get, and I'm talking about staying apples per apples, ones that, you know, that they use the brush type of ionizers, they're about $100 cheaper. These aren't cheap. Your cheapest solution would be UV lights, but like I say, you know, you use those at your own risk as it relates to messing up any coating on your evaporator, any plastic pieces, also in your flex ductwork. It will deteriorate that. Your the ones that use hydrogen peroxide, since they still use UV lights, some UV light does get out. They're not completely encased in those metal cells. And so you could also get UV light on other plastic pieces with those too, not to mention the cost. But PlasmaAir, the representative that I spoke with was, which I didn't ask him if he was okay with me giving his name, so I won't mention that on this particular video, but he was super nice, very informative. He feels that their products are superior because in internal testing that they did, these are rated to basically 6-ton units, or what was it? I think it was 2,400 CFM. And basically, the real rough calculation that you can do is for every ton, that's that equates to 400 CFM. So these are, one of these units should be able to cover up to 2400 CFM, which is like a 6-ton unit. My units are 3-ton downstairs, and I think 2 upstairs. So these are more than adequate for that airflow. The air handlers actually are about 1400 CFM. So actually that calculation isn't pure, but you have to also think that regardless of what it's rated at, the air is going to get slowed down going out of the ductwork, so that indeed either one of these units should be fine for most residential applications. So I think I've droned on enough about this. What I'm going to do now is pause the video, go up in the attic, speak just a little bit more, and then I will actually show you the unit after I have mounted it to my bracket and how it looks installed. So go ahead and pop. Hey guys, so now I'm up in the attic, and I'll show you my air handler. You can see on the return side where my return duct comes in from the ceiling upstairs. It comes in to return ductwork. Here's my air handler, and then here is the supply side where it goes out to the upstairs rooms. My air handlers, in both of my air handlers, the actual evaporator coil is first, and then the blower. That's actually called a pull unit. So that was one of the reasons, particularly, that I want to install my unit on the return side, so that the ionized particles can actually flow across my evaporator, get pulled through the blower, and then out. If indeed you have an air handler where the blower is first, to me that would be a much better argument for installing the ionizer right on the blower. Now what I have already done, and I'll show you this, is that on my return duct I've already marked where I'm going to cut my rectangular hole. What I will do to accomplish this is really straightforward. I'm going to drill 4 holes in each corner on the inside where the material is going to be removed. The simplest thing I found doing the one downstairs is actually drilling the 4 holes and then going back with 10 snips and cutting out this. After I have actually cut out the rectangle, then I'll have to actually use a little box cutter type of device. It's this device right here, to cut the insulation out. And what I typically, or what I did before and what I'll do this time, is I'll take a drywall screw and just run it through that insulation, so as I'm cutting it, I don't have to worry about it falling inwards. I can just easily lift it out. And then after I have that hole actually there, I'll mount the bracket. I'll put the bracket up there to mark my holes before I even put the ionizer on it. And then after I mount the ionizer on it, I'll be ready to just bring it up here, put it in the hole, and plug it in to this receptacle here that I added. And see, notice that it's actually only about 24 inches away from there, and I'll have it plugged in and my installation will be complete. For right now, I'm going to just mute the video, and I'm going to cut this hole out. I don't know that y'all want to see that because I'm being kind of wordy anyway, But like I say, I'm going to drill 4 holes, 10 snip it out, get that piece out, pilot my 4 little holes for my mounting thing, mount the ionizer on the bracket, and then mount it. So that's it for the moment. So I'm going to stop this, go downstairs, or actually mount this, stop this, and actually drill out my stuff here, and then I'll pick back up. Thank you. So just to show, at this point I've drilled the 4 holes. Now I'm going to go back with 10 snips and cut out my rectangle, and then I'll pick back up from there. Okay, just to show you a little bit further in the process, at this point I have actually cut the hole out with 10 snips, and I went around the insulation that was on the inside with the little box type of cutter. Prior to doing that, like I say, I used a drywall type of screw and kind of did that so as I was going around it, so once I was done I could just lift back with that screw, and now you see I have a nice opening. What I'll do now is I'll take some actual needle nose pliers and kind of smooth out this little edge that I made, and so it'll be a nice clean hole. I will put the bracket in place to mark my holes, pre-drill those a little bit, so I have a nice, real easy to screw the screws in once I'm done, and we'll go from there. Okay, at this point I've cut the hole, used my needle nose to kind of smooth out around the edges. I put the bracket in place so that I could do 4 little pilot holes for my bracket, and at this point I'll be pausing it again so that I can mount the ionizer onto the bracket and show y'all that and then install it. Okay, we're at the point where I've actually mounted the ionizer to the bracket that I showed y'all later. As you can see, the magnet is actually adhered to the piece of galvanized bracket, but I've also used actually lock washers. That's what's really holding it in place. There are screws you'll notice behind there that act as spacers, so that whenever I tighten the screws I would not torque down on the little ears of the ionizer too far. And what I did was I ran the wires of the ionizer through my bracket, and I actually had some 1.5" heat shrink tubing that I wrapped around there kind of loosely before I screwed and clamped down the wires. I don't think I needed it as much to protect the wires. I used it actually to seal that off, so air would not get sucked in into anywhere around there as you know, the actual air handler is running. And then what I did was the actual wiring, as you'll notice, it has a 0.5 amp fuse in line for protection. What I did was I used this, as I mentioned before, I used a polarized plug, and you can see the way they line up. The black wire is screwed down to the little connector, which is the hot on a receptacle, and then the return is going to the big one. Okay, so as I was saying, I used a male receptacle in that is polarized, so if I unplug this to pull the unit out to check the brushes, I don't have to worry about plugging it back in backwards. Now, to show you how it looks when it's functional, I'm going to plug it in, and notice indeed there's your green light. So now you know that the ionizer is working. But also notice, if I take my finger and I'm going to run it in between the ionizers, it feels like a breeze running on blowing against each side of my finger, and that way I also know that indeed it's actually working. And as I mentioned before, don't touch the ends. My understanding is that'll shock you, so you don't want to do that. So at this point, I am actually going to take the unit upstairs and actually screw it in. One thing I did want to also mention, earlier I mentioned that one of the main reasons I went with PlasmaAir and their 600 series, specifically the 603, is so that one is because they were about $100 cheaper than comparable products from other vendors. But the other thing is when I talked to the other vendors, who were nice to talk to also, but I will say that the PlasmaAir representative was exceptional, is that PlasmaAir, the other two vendors, Nu-Calgon and Bipolar, they require you to have their unit installed by an HVAC person. In checking around to get any of them to install a unit, costs between $750 and $900, and that's on top of the unit. Their units are 400 or more. And like I said, this unit, as small as it is, you think it would be $25, but no, it is still relatively expensive at $300, but it's still $100 cheaper than the competitors. The big thing, the beautiful thing about PlasmaAir is that they let you work with a distributor. Some of their distributors will sell to the public, and indeed, and they have a 3-year warranty like the other manufacturers, but with PlasmaAir, if you have an issue during the warranty period, you can work back through the distributor to get a replacement. The other two manufacturers require you to show a receipt that it was installed by an HVAC or electrician, depending on the vendor, which that, like I said, it makes installing such a device, quite expensive. So I'll give PlasmaAir a big thumbs up on that. If I had, like I say, I think earlier in the video, if I was to actually give them any advice, it would be one, use better adhesive on your magnet, maybe even redesign your can to where the magnet is recessed so that indeed maybe it would not come loose. Watch your quality control on your ionizers, that indeed they're where they should be in the cans. And if I was them, I would look at potentially making a bracket like this, and actually maybe selling it as a complete unit like this, to where someone like myself, it would be like a no-brainer to install, and you don't have to touch your air handler at all. All you have to do is cut a small hole in your return duct and you're done. So at this point, I'm going to pause the video again, go upstairs, let you watch me actually put it in the hole that I cut out and plug it in, and the install is basically done. I will go back and actually tie wrap the wires to make it nice and neat, so they're not just hanging down. Outside of that, though, the install will be done. Okay, so here we are. I'm ready to install the ionizer into the opening that I made. Notice that I made the bracket such that the air hits the D side, so the air will naturally, it won't be too much air as it's flowing around and coming across it, that it'll be the way they intended it to be. And so at this point, I'm just going to actually carefully and evenly put the air ionizer through the hole. And then I'm going to take my 4 screws that I had already previously piloted. Actually, let me get these started. better. Okay, so I got 2 of them started. I'm going to finish up the other 2. Okay, I screwed those in. The other thing I really like about this bracket is the fact that the plastic actually protrudes down some, so it won't let you actually screw it in too far and damage the plastic, and it provides a good way for letting you know whenever you've reached the maximum penetration, so you don't keep tightening in and over tightening it. So at this point the installation is actually complete. The only thing that I need to do now is actually plug it in, and we're done. I'm going to, like I said, take a tie wrap here and tie wrap this like this, just to make it a little bit neater, and you can see that you end up with an installation that lets your ionizer do exactly what it's supposed to do, actually cleanse your coil, get ions out in the air, and it is supposed to actually kill bacteria and viruses by the ions attaching to those molecules, and actually my understanding is it deprives them of their hydrogen, if I understand it correctly, but basically it will kill your bacteria and viruses. And as far as allergens, the ions connect, actually attach to those, making them physically bigger, so that they indeed will more easily get caught by your filtration, your filter. So if you use a good filter, you indeed get protection there. So the last thing I want to say, and I want to give a plug out to the people that I bought the ionizer from. I got those through Dayton Appliance Parts. I worked with specifically Mike Munn, and here is their telephone number, 800-538-7263. I wanted to give him a shout out. He was very good to work with and shipped me the pieces that I needed in a timely manner, and PlasmaAir themselves were very informative and helpful in picking the right product and the one that was most cost effective to accomplish what I needed. So anyway, for any of you guys out there, girls who indeed want to install an air purifier, hopefully me going over the different types and the pluses and minuses regarding to those, and that's how I came to the decision to use an ionizer based solution. Hopefully you'll find that information helpful, and that's all. Goodbye.